Hello everyone, welcome to this online course on material science. I am Dr. Imtiaz Ahmed. As I have mentioned in my first class that I will start this course with the topic magnetism, and this is module 1. In this first lecture, I will try to make some general comments about the magnetism as a whole. Let me begin by noting a fact that as a phenomenon, magnetism is really an old one. We have clear evidence that even the ancient Greeks knew about magnetism. But if you see in the current literature, magnetism is still an active area of research. I want to ask the question why this is the case. What makes the magnetism such a fascinating and challenging topic? Of course, what are the difficulties in explaining or understanding magnetism? In this lecture, my plan is to give you some ideas. And I want to start with a theorem which is due to Bohr and Van Leeuwen. Let me state the theorem first. It says in a classical system, there is no thermal equilibrium magnetization. So, if you look at this part of the theorem, it's telling us that there is no possible magnetization. But we know magnetization exists. We can see magnets all around, right? So, where is the catch? If you look this part of the theorem, you will see it says in a classical system. So, the take-home message from this theorem is that magnetism cannot be explained using classical system, or rather more correctly using classical physics. And magnetism is indeed a quantum mechanical phenomenon. The fact that you need quantum mechanics to understand magnetism properly makes the topic very fascinating and challenging. Because to understand what causes magnetism in a solid, you have to understand the dynamics and the interaction of different kind of constituents of the material. For example, electrons, we have ions, we have protons, we have neutrons. No doubt, the strength of the magnetism due to different particles can vary in the orders of magnitude, but the important point here is to understand that in order to explain the effect, you have to understand the dynamics and also the interaction in a quantum mechanical setup. That is indeed a difficult and advanced formalism in quantum mechanics. So, before I finish this lecture, I want to give you a list of things that one needs to know before he or she can understand magnetism. It turns out that, for example, if somebody want to understand why electrons or how electrons can cause magnetism in solid, it turns out that we need to model different physical aspects of electrons in a quantum mechanical setup. For example, we have orbital angular momentum, we have spin angular momentum of the electron, and we need to understand them in the quantum mechanical setup. And then we have to understand how this spin angular momentum interacts with the spin or with the orbital angular momentum, and the spin angular momentum interact with each other, which is spin orbit interaction. And overall, in a more advanced understanding, we need to understand how electron and electron interact with each other. This is indeed the most difficult part because it's a many-body effect, and we need really advanced formalism to understand this. And also, I want to mention that when you put a magnetic material in a magnetic field, in order to understand what happens, we need to model the interaction between the electrons inside the solid and the external magnetic field in a quantum mechanical setup. So I believe these are the things that makes this topic very challenging. I hope I have convinced you that if you stick to the classical physics concept, magnetism will be a very much approximate and incomplete idea. But if you use quantum mechanical consideration, then you will have a much better understanding for magnetism. And I hope at the end of this lecture I have a reference for you. If you want to read about some of these challenges, you can go and read the chapter 1 from the standard reference, Magnetism in Condensed Matter by Stephen Blundell, published by Oxford University Press. I think that's about it. In the next lecture, I will start from the very basic definition and notation to set the language in which we will try to understand magnetism. I think that's about it. Thanks for listening.